Hello and welcome to Prime Math Tutorials. Today we'll take a look at graphing the function x squared minus 4 all over x plus 1, and hopefully you gain something valuable out of it. Let's get into it. Firstly, we are required to find the intercepts. Now to find the x-intercept, we need to set y is equal to 0, or equivalently, f of x is equal to 0. Doing this, we get 0 is equal to x squared minus 4 over x plus 1. And then, multiplying both sides by the denominator of x plus 1, we get x squared minus 4. Now we can factorize x squared minus 4 using the difference of two squares to write this as x minus 2 times x plus 2. It follows that the x-intercepts are x is equal to plus 2 and x is equal to minus 2. Now to find the y-intercept, we need to set x is equal to 0. Simply substituting x is equal to 0 into our function, we get negative 4, as shown here. Okay, now for part B, we need to find any asymptotes. As the vertical asymptotes are usually easiest to identify, let's start there. Now remember, for these type of asymptotes, we need to see if there are any values of x which make the function undefined, and to do this, we consider what type of function we have. Since this is a rational function, our constraint is that the denominator cannot be 0. This means that x plus 1 cannot equal 0, which means that x cannot equal negative 1. Thus, our vertical asymptote is x is equal to negative 1. As an intermediary step, let's see what happens on either side of the asymptote. An easy way to do this is by plugging in values very close to x is equal to negative 1 into the function and evaluating this using your calculator. Doing this, we find that on the left side of x is equal to negative 1, substituting in a value of x is equal to negative 1.001, the function goes towards positive infinity, inferred from the large value shown here. And on the right side of x is equal to negative 1, using a value of x is equal to 0.999, the function goes towards negative infinity. This information will be useful when graphing the function. Let us now look at any other asymptotes that may exist. This function has an oblique asymptote and not a horizontal asymptote. This is because the leading degree of the numerator is 1 degree higher than the leading degree of the denominator. That is, x squared is 1 degree higher than x to the power of 1. Using the idea from the last video, we can now find an oblique asymptote using division. This function is a little more complicated to divide than the function in the other video, which had a denominator of x. To divide this, we need to use long division. Following the long division, we can utilize the idea that a polynomial, p of x, divided by some divisor, a of x, is equal to the quotient from the long division, q of x, plus the remainder from the long division, r of x, over the divisor, a of x. This means that x squared minus 4 over x plus 1 is equal to x minus 1 minus 3 over x plus 1, where x minus 1 is the quotient we found and negative 3 over x plus 1 is the remainder we found over our divisor. Now in this decomposed form, we can identify our asymptote as the term which does not involve a fraction. So in this case, our asymptote is y is equal to x minus 1, which I've colored in red. To confirm that our function is undefined when y is equal to x minus 1, let's set f of x is equal to x minus 1 in our original function and simplify. Doing this, we get x minus 1 is equal to x minus 1 minus 3 over x plus 1. This simplifies to 0 is equal to negative 3 over x plus 1, after subtracting x minus 1 from both sides. Then multiplying both sides by the denominator x plus 1, we get 0 is equal to negative 3, which is obviously false. Hence our denominator is undefined when f of x is equal to x minus 1. Now for the last part, sketching the curve. Here, we can write out the information we have accumulated from the past questions and present it in an easy to understand way. From our table of information, we can read off our x-intercepts, which are at x is equal to negative 2 and x is equal to 2, and the y-intercept as y is equal to negative 4. Following this, let's add in our asymptotes. We found that there was a vertical asymptote of x is equal to negative 1 and an oblique asymptote of y is equal to x minus 1. Additionally, it is worthwhile to quickly check if the function is odd or even. However, it is clear that this function is neither. Using our table of information, we know that the curve goes towards positive infinity as the function approaches the asymptote x is equal to negative 1 from the left side, so we can plot a point there as shown here. Similarly, using our table, we can plot a point at negative infinity on the right side of the asymptote. This step will make it easier to understand the shape of the curve. Now that we've put down nearly all the information we know, let's think about what the curve looks like. Starting from the point we jotted down on the right side of the asymptote x is equal to negative 1, we know that the curve must pass through the y-intercept y is equal to negative 4. Then it must pass through the x-intercept x is equal to 2, so that part is clear. But where does the curve go from here? Well, as mentioned many times previously, asymptotes provide a great guide for graphing since they show where the function converges to. So in this case, the function converges to the oblique asymptote y is equal to x minus 1. Now you may ask, sure, the function converges to y equals x minus 1, but why is it from below and not above? To have a clearer picture of why it approaches y is equal to x minus 1 from below, let's take a look at our decomposed function f of x is equal to x minus 1 minus 3 over x plus 1. Notice that for every x greater than negative 1, we are subtracting some positive value away from x minus 1, and as x increases, this value being subtracted decreases. This shows why the function converges to x minus 1 from below for x greater than negative 1. Now that we know the shape of the curve on the right side of the asymptote, let's take a look on the left side. Well, we know that we can start sketching the function around this blue dot here. The curve then has to go through the x-intercept, x is equal to negative 2, and then it converges to y is equal to x minus 1. Again, you may ask, why does it converge from above? Well, looking at the decomposed function, we can see that for every x less than negative 1, we are subtracting some negative value away from x minus 1, or equivalently, adding some positive value to x minus 1, which shows why the function is above x minus 1 for x less than negative 1. And as x approaches negative infinity, the value being added goes to 0, so the function goes to x minus 1 from above. Now that we know what the function goes to as x goes to positive and negative infinity, as well as when x goes to negative 1 from both sides, we can simply draw a line through these points and intercepts to sketch the function and finish the graph. Well, that's it for this video. I hope that helped, and if you have any feedback, please comment. See you next time.